Hello, welcome to limiting reagents and percent yield. So the concept of a limiting reagent, or a limiting reactant is an equivalent way of saying this, is a reactant that will be totally consumed in the reaction and actually will determine how much product will form. So a simple visual of this, if we were to have 5 hot dogs and we had 4 hot dog buns, theoretically we could only make 4 full hot dogs in buns. Our limiting reagent there is our bun, because if we had 5 buns, we'd be able to actually also use that excess hot dog there. So we get a leftover hot dog. That can also be referred to as an excess product, excess reagent that's left over from that reaction. So an excess reagent is a reactant that you have more than enough of, and some will be left over when the reaction has gone to completion. So we're actually going to look at 2 concepts today. These are some of the most difficult questions that we will do in this unit. They involve a lot of work with stoichiometry, like we already did, and then kind of thinking about what you get and kind of comparing some quantities at the end. There are actually 2 ways to approach these. The first is kind of the official way to do this. So you calculate the number of moles of each reagent given in the problem. They're given in grams. And then you calculate how much you would need of kind of the other reactant or reagent in order to compare them. And then you can use that limiting reagent to determine the amount of products formed. I will walk you through this once, and then I will probably never do it again. What I do instead is I calculate the amount of product that would be formed based on each reactant, and I just pick the one that's less as my limiting reagent. It's just typically not described that way in college textbooks or other places where this is taught. So I'm going to show you the first way, but I think the second way is a little bit easier. So in this problem, we have copper reacting with sulfur to produce copper 1 oxide according to this balanced equation. So this is given to you nice and balanced. Sometimes you might have to write these, but it will depend on the problem. So we're going to look at first what we would have as our limiting reagent. So we start with our 80 grams of copper, and I do have the GFM labeled for that there, so we can go through this a little more quickly. When I have 80 grams of copper, I can change that into my moles of copper first. Then I'm going to use by reaction. What I'm actually going to compare in this approach is copper and sulfur. Okay, so what I'm looking at here is, which one of these do I have kind of essentially more of? So then I say, okay, I got 2 moles. Oops, keep looking around here. I got 2 moles of copper that will react with 1 mole of sulfur. And then I want to find out how many grams this is so I can compare it to the number of grams of sulfur that I'm given. So 1 mole of sulfur is 32.065 grams of sulfur. So mathematically what you're doing here again, you're going to do 80 times 32.065, and you're going to divide that by 63.55 times 2. So what this tells me is that if I react 80 grams of copper, it requires 20.18 grams of sulfur. Okay. Now, on the other hand, if I look back at my problem at this point, the amount of sulfur that I have is 2.5 grams. So I say, okay, what that actually tells me is that copper is my limiting reagent. Now, the other calculation that you would typically do is you'd say, okay, if I started with 25 grams of sulfur, and then I'm going to change sulfur into moles first, so 32.065 grams of sulfur is 1 mole of sulfur. According to my reaction, 1 mole of sulfur reacts with 2 moles of copper, and I need to put this into grams. So 1 mole of copper is 63.55 grams of copper. So if I go ahead and punch these into my calculator, 25 times 2 times 63.55 divided by 32.065 gives me 99.0, well, we'll round that to 99.10, sorry, 10 grams of copper that I would require. So what this tells me, I only have 80 grams of copper according to the problem. So this means that my, excuse me for just, sorry about that. My limiting reagent indeed is copper, because the amount of copper that I need, that I'm required to have according to my calculation, is greater than what I have. Since I have plenty of sulfur, you know, I can go ahead and react all that sulfur and I'll still have some left over. So then what I want to do is I'm going to go ahead and say, okay, how much of this copper sulfide will form? So since I start with my limiting reagent and the amount that I have above, beginning of this is going to look kind of similar because I need to change my grams of copper into moles of copper. But this time what I want to find out is how copper is going to relate to copper sulfide. So I have 2 in front of copper sulfide, or in front of copper, and 1 in front of copper sulfide. So 2 moles of copper produces 1 mole of copper sulfide. My grams of copper cancel, my moles of copper cancel. Now I've got a mole of copper sulfide. I actually want to know how many grams I'm going to get. So 1 mole of Cu, 2S. I'm going to look back up here to grab my gram formula mass, which is 159.157. Which takes me right into grams. So then you can go ahead and punch into your calculator, 80 times 159.157 divided by 63.55 times 2. So this tells us, you know, you'll get on your calculator 100.18. We are limited to 3 significant figures, so our limiting number is the 80 grams right here. So this means we will get 100 grams of copper sulfide, based on knowing that our copper limits our production of copper sulfide. Now, exact same problem, different approach. I like this approach a whole lot better. I think it's a whole lot easier. So what I typically do is I say to myself, hey, I'm going to go ahead and I'm going to calculate how much product I would make from using either of the reactants, okay? So the first thing that I'm actually going to do is the same calculation that I did right here. Now I'm going to pause the video and copy that over. There's no reason to do it again. So we already know from doing this problem once before that this is the actual amount of copper sulfate that we'll make based on knowing that copper is a limiting reagent. However, if we were doing this problem for real, we wouldn't know that at this point. So what I'm going to do in addition to this is I'm going to take my 25 grams of sulfur and I'm going to determine, if I started with 25 grams of sulfur, you know, how much product I would make. So my GFM for sulfur is 32 points. Oops, sorry, let me go back for just a second. 32.065 in 1 mole. I'm comparing how sulfur will produce copper sulfide. So 1 mole of sulfur produces 1 mole of copper sulfide, and 1 mole of copper sulfide has a mass of, I'm just going to go back for a second, 159.157. So what I did here that's a little bit different is I didn't compare, oh, I'm starting with this much copper, how much sulfur would I need? I skipped that step and went right to determining the product that I would make, but you have to calculate how much product you would make using both reactants. You have to be able to make that comparison. So if you punch this into your calculator, this would allow you to make 124 grams of copper sulfate. So when you're answering the question of how many grams of copper sulfate are going to be made, you have to take into account that we don't really have enough copper to make this. So we don't have enough copper to actually make this many grams. So we are going to make 100 grams. So the answer still is exactly the same. We're going to make 100 grams of copper sulfate. or copper sulfide, sorry, but we approached this in a different way, and I think this saves you a little bit of time, makes it, you know, just 2 calculations instead of really doing 3. So I'm going to pause the video for a minute, take a minute and walk through this problem. I'll put the answer up in just a moment. By the way, here is your reaction, so you can just double check that to make sure you have the right mole ratios as you go forward. So at this point, if you have figured out how many grams of H2 you'd be producing in each of these, if you used 5 grams of magnesium, you're able to make that much H2. If you use 6 moles of hydrogen chloride, you're able to make this much H2. So hydrogen chloride is our limiting reagent. This is how much we'd produce. And yes, HCl is our limiting reagent. One type of related problem to this is something called a percent yield problem. So percent yield, actually you take you determine a theoretical yield, which is what we were doing in the last set of problems, but you're told by the problem that you really didn't make that much because, you know, like lab error and like human stuff. And you actually then go and determine your percent yield based on how much you really should have made. So what you're going to do first is you're going to go ahead and determine how much of the product you think you should have made. So I'm going to pause the video again, or actually, I'm not going to pause the video. I will show you your theoretical yield here. Your theoretical yield for this is 10.8 grams, and this is of antimony. So that's based on the type of calculation that we did before. I'll pause the video and put this up in case you want to be able to check if you tried this problem. So one step saver in this problem is it is telling us we have an excess reagent. We have as much iron as we could possibly need. So we do really only have to do this one step to find out that we expect to produce 10.8 grams of antimony. Now, it is telling us in the problem that we actually produced 9.8 grams. So our actual yield, so we're going to look at putting for our percent yield, we're going to put our actual yield of 9.84 over our theoretical yield of 10.8, those are each in grams, and we're going to multiply this by 100. One little tip in percent yield calculations, it's a type of percent where the thing on top does have to be smaller. So if your theoretical yield is smaller than your actual yield, you know that you calculated your theoretical yield incorrectly. So this gives you a percent yield of 91.1%. And we'll be practicing these more in class, so I'm going to stop the video here.